Okay, so hello everyone. This is week 15 of our previous year questions discussion, and we will be discussing today engineering mathematics. So, what I decided was we'll keep today's session a little short, and also because of the power cut, I have started the session a little early because I don't know how much mobile data and battery, my laptop battery and mobile battery are going to last. So you may be not be able to join the live session because it's I think half an hour early. And but you can still see the recording. I always upload the recordings in the YouTube channel, and I see that you people have been keeping up with those, so you can look at it there. And if you have any questions, then we can always discuss in the session or in the comments. Okay. So yeah, so today's two topics are going to be Cauchy's theorem, basically for complex integrations seen in the complex number realm, and then a simple question of definite integral. And then we'll look into some more questions that have been asked and that can be asked from the complex numbers in the related to the integrals only, because complex number is not a very well actually asked topic in GATE. In ECE, it's there are good chances of this being asked, but in civil engineering GATE, it's not that popular. So we are going to look at only some theorem-based questions, and then we'll look into Green's theorems. Green's theorem one question, because I thought while we are looking at the integration theorem, this Green's theorem is very popular. So why don't we just look at that also? It is just a simple formula based question for Green's theorem, because that is the only type of question that I have seen being asked in the GATE. So we'll look into that just to refresh the formula, because more than anything what I have seen is these type of questions when they come, it's not that we are lacking the concept, it's just that we don't remember the formulas. So just to jog your memory of the formula, we'll look it into Green's theorems. All right, so this is a question regarding Cauchy's theorem of integral in complex number space. So let's look at this. All right. So we have to find the value of integral that is given here, and which is uh, where the curve C, for the closed curve, that is C, where the curve C is represented by the following equation. So what does this equation mean? This equation means that Z is basically a complex number x plus I into I, and mod Z is nothing but x square plus y square. So if you look at this in a complex space where this is imaginary axis and this is real axis, this particular mod of Z is equal to 1 represents a circle of radius 1. And we have been asked to find the integral of this particular function, that is, change the color here, f of x, or maybe let's say f of z would be better, cos of 2 pi z by 2z minus 1 z minus 3. We have to integrate this function along this closed curve that is given. Okay, so let's look at Green's function. Let's look at a function. Sorry, not the Green's function. Let's look at Cauchy's theorem. What does Cauchy's theorem tell us? So Cauchy's theorem basically says that if your fz, so you have this. This is the integral that you want to calculate now, and this is the curve C. If your fz is analytical, meaning that there is no point within this curve where your function is going to undefined space. Let's say it is becoming 1 by infinity, not 1 by infinity, but infinity, 1 by 0, 0 by 0. Not all these things are happening to your function within this space of your curve that is given to you. In that case, and this is a closed curve, in that case, the value of this expression will be 0. All right. So let me write it here. If fz is analytical and continuous within and also on a closed curve C, then everything is fine, and then the answer is simply 0. But if you look at this particular expression, z is equal to 1 by 2 in the denominator. If you look at this particular expression, z is equal to 1 by 2 will be one of the points where your function fz will be 1 by 0, which will make it not continuous basically. So we cannot use this theorem. So to remedy that, we have another theorem. And I like that theorem much better than this. What does that theorem tell us? That theorem basically tells us if fz is analytic within a closed curve and at any point within C. So and at any point A within the curve C, this particular relation will be followed. F of A will be nothing but 1 by 2 pi I, this closed curve, F of Z dz, dz, Z minus A. So we can simplify this as 2 pi I f of A is equal to integration of this function fz along this closed curve. Just we have divided the inside the integration by the factor z minus a. So that's what we actually see in our expression. So what is our expression? Our expression is nothing but cos of, let me put it as f dash z, or gz is nothing but cos of 2 pi z dz divided by 2z minus 1 and z minus 3, right? So if I were to write this particular expression as gz is equal to f of z divided by z minus 1 by 2, see, because z minus 3 is outside this particular curve, no? So we don't have to worry about that. We can write that. Then in that case, f of z will be nothing but 1 by 2 cos of 2 pi z. So let me put here integral, or maybe let me remove this integral here and remove the dz from here. Yeah, it will be 2 pi z divided by z minus 3. This 2 in the denominator will come because I have taken here 2 common from the denominator and taken it out, so that we have a nice expression of z minus a as we have seen in the theorem. So when this is true, then you can see that our integration, that is cos of 2 pi z dz 2z minus 1 z minus 3 will be transformed into 1 by 2 cos of 2 pi z dz z minus 1 by 2 z minus 3. And further, we can write it as 1 by 2 f of 1 by 2, which is 1 by 2 f of 1 by 2 into 2 pi I. So it is pi into I into f of 1 by 2. So instead of z, we have to put 1 by 2 into the expression, which is this. Actually, we have already taken out the 1 by 2 common, so I should not do this. Yeah. Let me correct this. Let me write this correctly so that we don't make any mistakes. So basically, it will be 2 pi I into f of 1 by 2. Exactly. So 2 pi I into 1 by 2 cos of 2 pi 1 by 2 here by 1 by 2 minus 3. Right? So let us simplify this expression. We have cos of pi because 1 by 2 got cancelled, and we have 1 by 2 minus 3. So basically minus 5 by 2. So cos of pi will be minus 1. So minus minus will get cancelled. So we will get 2 pi I by 5. So let's see if this is in the answer. So 2 pi I by 5 is one of the answers, and this is correct. So I hope you understand. This was a just simple formula based question, theorem based questions, and I have discussed a particular theorem with you. This is the theorem. And don't worry about going into much of the detail related to these kinds of problems or complex numbers, because that is more of a ECE kind of domain. We as civil engineers, we don't deal with complex numbers as much. We have to worry about bending moment, shear force, and all those things that they don't have to worry about. Okay. All right. So let's look at this question. Second question. Solution of the differential equation 3y dy by dx plus 2x is equal to 0 represents a family of what? So when I looked at this equation, I was very tempted to use the particular classification of PDEs, right? That b square minus AC and all those things. Less than 0 elliptical equal to 0 parabola, greater than 0 hyperbola. So I was tempted to use this, but then this is not PDE, this is not partial derivative, this is complete derivative. So we cannot use that. So what is the other way to identify this? If you look at this question carefully, this is a very simple question, right? So if you look at this, we have 3y dy by dx plus 2x is equal to 0. Y is with dy, which means we can integrate it if we can remove this dx from here. So why don't we multiply this whole thing with dx, and in doing so what will happen is 3y dy plus 2x dx is equal to 0 into dx, which will be 0. Now you can integrate this expression actually. So we have 3y square by 2 plus x square by 2 into 2 will get cancelled, and then that is equal to some constant, because if you integrate this here, you have to integrate this also, and that will be some constant k. All right. So what can we do? We can further write it as, why don't we bring this particular constant on the denominator of these things and keep this right hand side equal to 1. So if we do that, we will have 3y square by 2k plus x square by k is equal to 1. And further, let's even simplify this further. Then we have our, let's divide this expression, or maybe let's write this expression like this, 2k by 3 plus x square by k is equal to 1. Does this look familiar? Can this also be written as, or here we usually write it as this x square by a square plus y square by b square is equal to 1. Doesn't this look familiar? This is actually equation for ellipse, isn't it? Where a and b are the minor and major axis. So it can be a, b, whichever, depending on what is bigger, it will become major axis. What is smaller will become minor axis. All right. So this is the answer. We can simply integrate this and we can get the answer. So that is what was asked of us in this particular question. We didn't have to go about looking into the classification formulas. But if you have spent some time in all those things, then you will be tempted actually to do to use that for this classification. And when you do that, as a matter of fact, if you try to do that, you will not be successful because that expression is dy square by dx square and then plus, sorry, it is df and d2f by dx dy plus d2f by dx square a b c. These terms are not even here in this particular equation, so it won't be helpful to do that. If you have not seen these kind of equations, then no need to worry about this. This is not in the syllabus. Okay, now just a minute, I'm getting a call. Let me see. This is just a minute, please. Hello. Yes, who's this? Sorry guys, I apologize for that. Okay, so let's go to the next question. Using Cauchy's integral method, the value of the integral given here in the counterclockwise direction is. So we have to use Cauchy's integral theorem and give the answer for this. Okay, so let us see what we can do here. Okay, my system is not working for some reason. Okay, finally. I don't know how long it is going to last, so let's just quickly get this over with. So you are not given any curve here. So they have said this integral is based on the closed for the closed curve C, but they have not actually mentioned the curve. What to do in that case? You use the same concept and you imagine that there is a curve inside which the point z minus I is going to become 0 and this function is going to become non-continuous. So that point is going to be z is equal to I by 3. So if you are having any confusion, this is I. That's why I am writing z is equal to I by 3. If that is the case, then what you do? Then what is the answer simply? You just say that my fz is not z cube minus 6 by 3 z minus I. My fz is only z cube minus 6 by 3, and whereas z minus a will be similar to z minus I by 3. And when you do that, then your expression transforms into let me write the intermediate step. Yeah, so your expression transforms into 2 pi I into f of z, where z is equal to I by 3. So this is your expression's final form. And when you do that, when you substitute the values, you have I by 6 cube minus 6 divided by 3. So let's try to simplify this. I by 6, it's I by 3 only, my part. So minus I divided by 27 minus 6 divided by 3. 3 I have already taken out, so you don't need to worry about that. Okay, so you are going to have 2 pi I and into minus I divided by 3 into 27, that will be 81 minus 4 pi I. Yeah, and I square is again minus 1 and minus 1 1. So you will have 2 pi by 81 minus 4 pi I. Right, this is going to be your answer. All right. Finally, after all this trouble, we are able to get the solution. All right, so we are back. Okay, luckily we are back. We are back, luckily. So this internet connection is not very stable. I will suggest that we finish this session of ours very quickly. Okay, so the value of integral, this particular integral for the curve. So now they have given the curve. So we are given an integral, basically definitely a complex integral where z is x plus iy, and we are asked to perform this integral on a closed loop, where this loop is the same as we have seen in the first question. It is basically a circle on the imaginary and real axis with a radius of 1 unit. So let's look at this function z square plus 4z plus 5. If you want to get the roots, let's see if we can get any complex roots that are within this region of the circle. Okay, so let's see. So minus b, that is minus 4, plus minus b square, 4 square 60, and minus 4ac is 4 into a is 1 and c is 5. So this, and then divide by 2a, so 2. Z is equal to minus 4 plus minus root under minus 4 by 2. So z is minus 4 plus minus 2i by 2. So we have minus 2 plus minus I. Okay, so let's plot these points. So first is, let me use another black plot to plot this. So what is the first point? Let's say minus 2 minus I. So this is our circle. This is minus 1 plus 1 minus I plus I. Minus 2 minus I minus I. So this is our first point. Second point, minus 2 plus I. This is our second point. Both of these points, they are outside the circle. That means inside the circle, our function is continuous and is fine. In that case, the first theorem that we have not used till now will come into action. That is, if your function is fz is analytic and it is continuous, then in that case, within this region C, in that case, fz dz will become 0. Simply you have to check the roots for this, you have to check the roots for this particular denominator function. You found out that they are outside and you use the first theorem and you get the answer of 0. That's it. Okay. Now let's look at the last question for today. So here we'll see the Green's function. I have written by mistake here Green's curve. Ignore that. This should be Green's theorem. Use Green's theorem to calculate the integral this for this closed curve. All right. What does Green's theorem tell us? Basically, we use a Green's theorem to convert or transform the integral in a plane region to line integral on the boundaries over boundary. All right. And what does this integral look like? What does the theorem look like? So if you have integral over a closed curve of some function f1 dx and some other function f2 dy, that can be written as integral over a boundary of that curve, or integral, a line integral of a double integral form, df2 by dx minus df1 by dy, and it will be dx dy. So looking at this particular function that you have above, can we identify what is f1? F1 is the one which is multiplied with dx, that is xy square plus x square. F2 is the one which is multiplied with dy, that is 4x minus 1. So my df2 by dx will be 4 and df1 by dy will be 2xy. Isn't it? Right. So what can I write? How can I write this expression? Double integral. One will be with the x, one will be with the y. We'll decide on the limits. 4 minus 2xy dx dy. Now look at this particular curve that you have. So this is y-axis and this is x-axis. X is going from minus 3 to 0. Y is going from 0 to 3. Right? You can perform this integration by taking a strip along this, by taking a strip along the y-axis and moving it along x-axis, or you can perform this by taking a strip along x-axis and moving it along y-axis. So if you look at this particular curve, can we get the equation for this line actually? Because anyhow we will need to know the equation of this line to put the limit either for x or y. So can we get y equal to mx plus c, the equation of that line? The line is passing through minus 3 0 and 0 3. Slope of this line seems to be 1. So if I were to write line y equal to mx plus c, m is equal to 1 because the slope of this line is 1. What about c? What is the intercept? Intercept is 3. So y equal to x plus 3 will be the equation of this line. C is nothing but y-intercept, and that we can easily see from this location that it is going to be 3. So yeah. Now that we know this, let me choose, let me erase this first. Let me choose a strip along the y-axis. This is going to be my strip. It is going to go from x equal to 0, or sorry, y equal to 0 to y equal to x plus 3. Okay. And then this will be strip along y, and that strip is moving from x of minus So this integral will become like this, right? And we can simply solve this. So first let me solve this inner part. This is integration with respect to y. So it will be 4, integration will be 4y minus 2x y square by 2. So we can simply write as 4y minus x y square. And the value of y we have to put here is 0 x plus 3. So 4x plus 3 minus x plus 3 whole square. 4x plus 12 minus x square plus 9 plus 6x. 4x plus 12 minus x cube plus 9x, oh sorry, minus 9x minus 6x square. So finally upon simplification we get x minus x cube and minus 5x minus 6x square plus 12. Okay, so this is my expression. Can I integrate it? I can easily integrate this over the given limit. So minus x4 by 4 minus 5x square by 2 minus 6x cube by 3 plus 12x minus 3 to 0. And when I put the values, first of all values is for first values will be for 0, so it is going to be 0. Then minus of values for x power 4, so minus 3 power 4 by 4 minus 5 minus 3 square by 2 minus 6 minus 3 cube by 3 plus 12 minus 3. So you have 0 minus of minus 3 power 4, 9 square, it's 81 by 4 minus 5 into 3 square 9. 9 4 is 45. Sorry, 9 4 36 divided by 2. So I did a mistake here actually. It should not be minus 6 into 27 by 3. It should be plus 6 into 27 by then minus 36. So this is going to be your expression. When you solve this particular expression, you are going to get the value 99 by 4. All right. So this is the final answer for this question. I hope you can understand how we have this, have what is the Cauchy's theorem, how to deal with that. Then one simple parabolic expression, and then some more related to the concepts of Cauchy's theorem. And finally, I wanted to just let you revise or have a recall of the Green's theorem. So we have done that, and that's all for today's discussion. All right, so thank you guys, and we'll meet again in the next session.